Hello friends, in this lecture we are going to discuss about benzynes. So let's see. In last lecture we have already discussed some basic points about benzynes. So just recap that points. First, these are nucleophilic substitution reactions. Means in case of a benzyne generation, means benzyne as an intermediate, it gives nucleophilic substitution reactions. In case of a normal benzene, it gives electrophilic substitution reaction, but benzyne gives nucleophilic substitution reactions. Then benzyne intermediate reactions are elimination addition type of reaction. Means first there is elimination takes place which gives you benzyne as an intermediate, and after addition reaction takes place. So it is elimination addition type of reaction. And benzynes are highly unstable species. Means benzyne as form as an intermediate and they are highly unstable. Means for the instability of benzyne, this triple bond is responsible actually. So as they are highly unstable, they are highly reactive too. Just see some basic concept about benzyne. The main difference between benzene and benzyne is presence of one more pi-like bond in this benzyne structure. Just see. In case of a simple benzene molecule, we have three pi bonds, right? And each carbon atom is joined with two adjacent carbon atoms and one hydrogen atom. Then for this whole ring means all six carbon atoms and all hydrogen are present in one plane, and pz orbitals, unhybridized pz orbitals are present perpendicular to that plane, right? In case of a benzene, here you can see each carbon atom is attached with each carbon atom is sp2 hybridized, so it has three sp2 hybridized orbitals. Each orbital means in case of a one carbon, that carbon atom is joined with two adjacent carbon atoms. Suppose in case of this carbon atom, it's joined with this carbon atom with sp2 hybridized orbital, second carbon atom with this sp2 hybridized orbital, and third sp2 hybridized orbital is joined with this hydrogen. And unhybridized pz orbital which will be present here. As for this, it's perpendicular to the plane, and these pz orbitals are responsible for the pi bonding, right? But in case of a benzyne, in case of a simple benzene molecule, there is these sp2 hybridized orbitals are responsible for the bonding with hydrogen. As benzyne is a structure, or aryne is a structure, we can call it is 1,2-dihydrobenzene. 1,2-dihydrobenzene means we are going to eliminate or we are going to remove two hydrogen atoms adjacent at adjacent position. Means from 1 and 2 position, if we remove two hydrogen atoms from this sp2 hybridized orbitals, right? So after elimination of these two hydrogen atoms, you will get free sp2 hybridized orbitals, and because of overlapping of these two orbitals, the formation of new bond will take place. It will gives you benzyne. So this newly formed or interaction of this sp2 hybridized orbital is weak. Why? Because in case of simple pz orbitals, the distance between these two orbitals is not much more. But in case of this sp2 hybridized orbitals, you can see the bond angle will be more. As it is sp2 hybridized, the bond angle will be more, and because of that they are far apart from each other. So their interaction means their overlapping is not that much effective. So because of that, the this bonding or this overlapping, as it is not that much effective as compared to this normal pi bond. Also, it is much weaker than normal pi bond. As it is much weaker, it is more reactive. So the benzyne is highly reactive intermediate. We will get in any reaction, any means benzyne reaction as an intermediate. So for the conformation of benzyne as an intermediate, there are different reactions. We can use trapping reagent for that, and much more important reaction shown by benzyne intermediate. Let's see one by one. In last lecture, we were discuss about aryl halides. On treatment with a strong base, they gives you benzyne as an intermediate and final product formation. See its mechanism actually. So aryl halides on treatment with a strong base like KNH2 or NaNH2, it generates a benzynes. Okay, so we have one aryl halide, that is a bromobenzene, and in presence of NaNH2 and liquid NH3, it will give you ipso substitution product and syn substitution product. Ipso substitution and syn substitution. See, we have this bromobenzene in presence of NaNH2. This NH2 will act as a nucleophile, right? This NH2 will act as a nucleophile. It will abstract one hydrogen, and as per that, the reaction will proceed. Let's see. But firstly, before that, we clear one point. In case of a ipso substitution, see, in case of a ipso substitution means what? If substitution takes place at same carbon, means firstly bromine present at this carbon, and after reaction substitution will take place, this NH2 will be substituted on same carbon, then it's called ipso substitution. And if substitution takes place at adjacent carbon, this one is the main carbon atom, and if the substitution takes place at this carbon or this carbon which is adjacent to this first carbon, then this type of substitution is called syn substitution. Ipso means on the same carbon and syn means on the adjacent carbon. Okay, so this benzyne intermediate reaction of aryl halides will give you ipso substituted product as well as syn substituted product. Let's see its mechanism. So firstly, we have this bromobenzene in presence of NaNH2 and liquid NH3. The first point we have discussed that it is elimination addition type of reaction, means first there will be elimination and then addition of nucleophile takes place. Let's see, we have this bromobenzene. Now in this case, firstly we have to see is there any alpha hydrogen present or not. So in this case, for this bromine, this carbon containing bromine, right? So at this carbon there is alpha carbon, this is alpha carbon as well as this one is alpha carbon. So hydrogen present on alpha carbon is alpha hydrogen. So you have to see there is presence of alpha hydrogen is not, or is it present. So in this case we have two alpha hydrogens. In this case we have here one alpha hydrogen and this one is second alpha hydrogen. So we have this two alpha hydrogens. Now NH2 may abstract any one hydrogen as it is a symmetrical structure. It can attack on any hydrogen. So let's see if it is attack on this hydrogen, electrons means if it is attack at this hydrogen, electrons will shift here. Here will be formation of new pi bond like bond, and this electron will shift on bromine and bromine eliminated as an Br minus. So you will get this 3 bond type of structure and it is called as a benzyne, right? This is intermediate. Very reactive intermediate is a benzyne intermediate. So now our reaction condition is firstly we have this NaNH2 in presence of liquid NH3. So up to NaNH2 nucleophilic substitution reaction or elimination reaction takes place, right? Firstly this NH2 from this NaNH2, from this NH2, right? NH2 will abstract one hydrogen atom, as we are going to remove this hydrogen and bromine, right? This hydrogen and bromine we are eliminating out, so it is an elimination step. So benzyne intermediate containing elimination addition. So this up to this it is elimination step. Now we are going to add something, that is in presence of liquid NH3, means we are going to add this NH3 molecule. So out of this NH3, suppose this NH3 lone pair containing NH2 and one more hydrogen is present at this nitrogen, right? But after addition, you will get this type of structure. Suppose this NH2. Now the possibilities are different. This NH2, okay, this NH2 may attack on this carbon or it may attack on this carbon. Are you getting my point? This NH2 lone with this lone pair may attack on this carbon or it may attack on this position. So different type of product you will get. But as the structure is symmetrical, the both product will be same. So you will get finally only substitution of this NH2. So you will get, if this lone pair, this nitrogen with its lone pair attack on this carbon, this electrons will shift here. So it will contain a negative charge, right? But this negative charge will abstract one proton which is eliminated by this NH3. One more hydrogen will be there and it's eliminated as a proton. So this minus charge will abstract that proton and you will get simple aniline molecule. Now as the structure is symmetrical, there is no separation in case of ipso substitution or syn substitution. So it is a simply aniline you are getting. But if there is any substituents present on this aryl benzene, then aryl halide, then you will get different type of products. Let's see one by one. If there is a meta substitution, then which type of product we will get. If there is a para substitution, then which type of product we will get. Let's see one by one. Suppose we have this type of example, that is we have bromo metabromo toluene. Then in case of NaNH2 and liquid NH3, let's see its mechanism. Firstly, simply we have NaNH2 and liquid NH3. So this Na plus and NH2 minus, Na plus NH2 minus. So first condition काय आहे की आपल्याला अल्फा हायड्रोजन बघायचं. We have to see any alpha hydrogen is present or not. So we have two alpha hydrogen, this one and this one, right? Carbon present to adjacent of this bromine carbon at which halogen is present. So this one is alpha carbon and alpha hydrogen. There is alpha carbon and hydrogen present on this carbon is alpha hydrogen. So in this structure we have again two alpha hydrogens. Okay. This two alpha hydrogens we have. Now this NH2 will attack on this. This NH2 will abstract any one hydrogen. It may abstract this hydrogen or it may abstract this hydrogen. If it is abstract this hydrogen, then product will be different. If it is abstract this hydrogen, product will be different. Let's see one by one. Means firstly we have two possibilities. So in case of first possibility, this. If this NH2 abstract this alpha hydrogen, electrons will shift here. And again this Br removes out as in Br minus. So this up to this it is elimination reaction, right? Elimination addition मतलब फक्त elimination up to this. Then second is benzyne formation takes place as these electrons are shifting here. These electrons are shifted here. There will formation of 3 bond, right? After we are adding liquid NH3, that is our second, the reaction contain medium containing liquid NH3. So from that this NH3 will attack on this species. Now the again two possibilities. If it is attack on this carbon atom or it attack on this carbon atom. Another two possibilities are there. See the first possibility. If it is attack on this first carbon atom, then this electrons will shift here. So there will be a negative charge on this carbon atom as per this. Again in this NH3, one hydrogen will be attached here, right? NH2 and suppose if I write NH2 and hydrogen is here, this minus charge will abstract one hydrogen from this NH3 and you will get substitution of hydrogen here and simply toluidine molecule, right? And the next possibility in this molecule, the next possibility of attack at this carbon atom, like this. Suppose this lone pair of electron attack at this carbon atom, electrons will shift here, means in next step minus charge will be on this carbon atom, right? And nextly one hydrogen which is present on nitrogen will be abstracted by this negative charge and simply you will get another toluidine molecule. Okay, now this one was first possibility. If this nitrogen atom or this lone pair attack on this hydrogen or abstract this hydrogen, then these possibilities are there. But if it is attack this hydrogen, then the second possibility is like this. If this lone pair abstract this hydrogen, electrons will shift here. There is a formation of one double bond and this electrons will shift on bromine and Br minus eliminated out. So you will get this type of benzyne. Now again there is a two possibilities. Which two possibilities? If this lone pair will attack on this carbon or attack on this carbon. Let's see one by one. In first case, if this NH3 attack on this carbon, electron will shift on this carbon. So we'll get negative charge at this carbon and that negative charge will abstract one hydrogen from this NH3 and you will get simply substitution product, that is aniline, means toluidine molecule. Again the second possibility, what? In this first possibility, this nitrogen attack on this carbon takes place. In second possibility, if this lone pair attack on this carbon, this electrons will shift here as per this, right? So after electrons will shift here, here will be a negative charge and this negative charge will abstract or takes up one hydrogen or proton from this NH3 molecule and simple substitution at NH para position. So out of this all products, these are four final products. First one is when there is abstraction of this hydrogen takes place, you are getting these two products. And second possibility, when this nitrogen abstracted this hydrogen, then these two products are forming. But out of these four products, two products are same, right? Out of this four toluidine molecules, this is orthotoluidine, this is metatoluidine, this is also metatoluidine, and this one is a paratoluidine. So you are getting first product, that is orthotoluidine, second product, that is 2-metatoluidine. We are getting these two products are same, both are metatoluidine, and third product is paratoluidine. So when there is a meta substituent, when there is a meta substitution compound is there, we are getting three product, right? First, second, and third. Now the second condition, if this bromine atom is present at para position or any substituent is present at para position, then what will be the product? Let's see. So this type of compound we have para-bromotoluene molecule in presence of NaNH3 and liquid NH3, NaNH2 and liquid NH3. So firstly, this NH2 will simply abstract alpha hydrogen. Now in this structure, which alpha hydrogens we have? This one, this carbon containing bromine. So alpha carbon is this. So here is one alpha hydrogen, and second one is here is one alpha hydrogen. See, this structure is symmetrical, right? So both alpha hydrogens are symmetrical. Any one it will abstract and it will give you same product. So let's see one by one. Firstly, this lone pair of nitrogen will abstract one hydrogen and electrons will shift here, then Br minus eliminated out as normal elimination reaction. So you are getting this benzyne as an intermediate. Now as it is very reactive, it will again immediately react with this liquid NH3, means this NH3 will attack on this benzyne, right? So now again there is two possibilities in case of this attack of NH3. If NH3 molecule with that lone pair attack on this carbon or this carbon, see the first possibility, if it is attacked at this carbon, electrons will shift here. So again here is formation of negative charge which will abstract one proton which is eliminated by this NH3, and you will get this meta substitution. This NH3 will attach here, right? So you will get meta substitution product like this. And in second condition, if this NH3 attack at this para position as per this, so you will get after attack of this at para position, electrons will shift here, negative charge will be here, and that negative charge will abstract one hydrogen from this NH3. You will get simple para product. That is, if there is a para compound, we have this para substitution compound, then we are getting two types of compound. In case of meta substitution, we are getting three types of compound, three types of product, that is ortho, meta, and para. But in case of para substituted compounds, we are getting only two compound, that is meta and para. There is no ortho, right? This is all about aryl halides we have. Nextly we see some reaction about benzynes. See, when benzyne is simply reacted with potassium salt of tertiary butanol in presence of DMSO, it will give you simply elimination addition type of product, that is this O minus, as it is a nucleophilic substitution reaction, O minus, right? Minus, it is a nucleophile, so O minus will be attacked here and electrons will be shifted here. Simply elimination addition type of reaction, you will get a final compound, right? See the next. Benzyne, if reacted with benzoic acid. Benzyne is reacted with benzoic acid. See, benzoic acid contains C double bond O, OH. So O minus H plus. So this O minus simply act as a nucleophile, attack on this benzyne, any one of this carbon, as it is symmetrical structure. So after attack, it will give you up to this formation of benzyne. See, up to this formation of benzyne, we have already completed elimination reaction. So because of that, benzyne formation takes place. Now we are going to do addition reaction. It is simply addition reaction. So after elimination reaction, we getting benzyne, and on this benzyne we are doing addition of this any other nucleophile. So this C double bond O, that is carbonyl, and O minus H plus. So that O minus will attack on this. Electrons will shift on this carbon atom. Here will you get negative charge, and this negative charge will abstract this proton. right? And you will get simple substitution product, that is phenyl benzoate. Means this whole compound here, this whole compound with this O, C, O and phenyl ring, this whole compound is substituted on this benzene ring. Okay, so it is a phenyl benzoate. Simple substitution reaction. See the next one. If we have compound furan plus benzyne, what will be the product? Simply we have a first benzyne compound, right? If we are going to add this benzyne with a furan, simple addition reaction. This type of addition reaction, it's called cycloaddition reaction. When there is a formation of cyclic compound takes place, cyclization takes place, then it is called cycloaddition reaction. It's one type of Diels-Alder reaction. In about this all we will see in pericyclic reaction in detail. So just see about this in now. In case of furan plus benzyne, see, there is, in case of cycloaddition reaction, new formation of some pi bond takes place, formation of new sigma bonds takes place, and some pi bond or sigma bond breakdown also takes place. So see, in this type of reaction, if this electron shift on this carbon atom, means new sigma bond will form between this carbon atom and this carbon atom. Then this electrons will shift on this, means this, in between this and this carbon atom there will be formation of new bond, and this electron will shift on this carbon carbon bond. It is a pericyclic reaction. Okay, see, as per this, if these electrons will shift on this carbon atom, then on benzyne, that benzyne electrons from that triple bond will shift between this furan and benzyne, and electrons from this furan will shift on this carbon carbon single bond. So you will finally get a 6-membered formation, ring formation, as per this, right? So newly pi sigma bond formed between this carbon and this carbon, and this carbon and this carbon, and newly formed pi bond in between these two carbons. So you are getting this type of compound. Now protonation takes place. After protonation, as this oxygen is containing lone pair, it will abstract simply hydrogen, means proton, and you will get this type of compound, it is protonated compound. Now as oxygen containing positive charge, it is unstable, it try to get stable itself. So this electrons from this OH will shift on this carbon carbon bond, and this electron will shift on this. Okay, so you will get this type of structure, that is this electrons, this bond will be break and electron will shift, this bond will be break, electron will shift on this carbon carbon bond, means new pi bond formation takes place here. One more bond will be formed here, that is a pi bond, and this pi bonded electron will shift on this carbon carbon sigma bond. So you will get newly formed another pi bond. So finally you will get, after this reaction, after this or moving of electrons, you will get alpha naphthol, means this bond will be break, OH will become free. Okay, this bond with this OH, it will become free, and here is a newly formed pi bond, and here will be a shifted pi bond. So this one is a newly formed pi bond, and this is one is shifted pi bond. So you will get alpha naphthol. Now it is aromatic compound. This naphthanol is a aromatic compound, and as it's maintained its aromaticity, it is more stable. So furan plus benzene, it is also one Diels-Alder type of reaction, cycloaddition reaction. It is a simple and most important reaction. Okay. See the next reaction. In case of a benzyne plus any olefin, olefins means alkene compound, double bond. We have a benzyne as our intermediate, and if it is reacted with any double bond compound, means olefin compound, alkene, then you are getting simple cycloaddition reaction as per the last reaction. It will form a cyclic compound, means here we are getting cyclobutane, 4-membered ring compound. Then second reaction is simple reaction, that is we can say about dimerization reaction. If we have two monomers of benzyne, then it will add, simply give you cyclization reaction. Okay, this one is the first molecule of benzyne. If it is reacted with second molecule of benzyne, simply electron shifting takes place, means this electrons will shift here, it will make up new sigma bond between two benzynes, and this electron from one benzyne will shift here and it will make a new bond between these two carbon atoms. Okay, see here. This electrons will make a new bond between this carbon-carbon atom, and as this electron shift here, it will make a new bond between these two carbon atoms. So you will get a cyclization reaction, means cyclic compound formation takes place. It's called electrocyclic reaction. Okay, or simply it is a dimerization reaction. See the next one. It is the most important reaction, that is benzyne if reacted with anthracene. Benzyne is reacted with anthracene. It is also a Diels-Alder reaction. See, I have written only as a simplified form. This is a This is a benzyne molecule we have containing a three bonds, and this is simply a anthracene molecule. Now 9 and 10 position is much more reactive. So in case of a Diels-Alder reaction, it will gives you shifting of electrons as per this. Means this electrons from this anthracene will shift here, and the new bond will form between this carbon and this carbon. This electron from this triple bond will shift here, means new bond will form between this carbon, and this electrons will shift here, and here is a new pi bond formation. Means in whole this electrocyclic reaction, there is a formation of this one sigma bond and second sigma bond and one pi bond as per this. Here newly formed sigma bond, here is the one sigma bond, this is the second sigma bond, and here will be a one pi bond. Just write it. Here will be a one pi bond. In case of a simplified form, you can write as per this. So yeah, here is the pi bond. You can see here. So this one is a also cyclic adduct, that is addition reaction of benzyne plus anthracene. You will get this electrocyclic compound, or cyclization takes place. This is a Diels-Alder type of reaction. So this is all about benzyne. In this lecture, we have all discussed about its basic points about benzynes and its some reactions of benzynes. Thank you.